Chapter 10, Section 6, number 19. For the data in exercise 19 of Section 2, like we've been doing, continuing on with that data, compute the coefficient of determination and interpret its value in the context of the amount of the medication consumed and blood concentration of the active ingredient. So the coefficient of determination, that is our R squared, and we can calculate that in a number of different ways according to that formula, whichever is the most straightforward in data we have. Let's jump back to our data that we've been looking at for this series of problems, which I've done in Excel. Multiple ways we can do that. Since R squared is the linear correlation coefficient squared, we'll just take the linear correlation coefficient times itself there in D22, and that gets us the value of our R squared, our coefficient of determination. So that's 0.913. Let me jump back over to our other sheet. So R squared equals 0.9. Is it 913 or 931? Let me go back and look. 931. Not sure what I said out loud a moment ago. Anyway, it's 931, or this is at approximately 93%. So our coefficient of determination. And as we mentioned out of the definition, the proportion of variability in x that is accounted for by the linear relationship between x and y is 93%. So the proportion of variation in blood concentration is accounted for by the amount of medication consumed 30 minutes prior. Well, that's all there was on this one. Another quick one if you'd watched number 11.